Welcome, guys and girls. I'm pretty sure
Hello.
you've got
Hello.
something amazing prepared for us, so the floor is yours, Nastya. Kick it off.
Thank you, Gleb. Thanks. So welcome, everyone. So that's a great conference, and we still have a piece of great content ahead of us. So first of all, I would like you to teach one very nice tip. So if you would like to learn a little bit more of English and practice it a bit, so what you can do, you can first learn C++, then get into the C++ Russia program committee. They will ask you to invite some guests. You might invite some international guests, and then you might have some small chats with them and practice your English. So that's why I invited this nice British dude. So but seriously speaking, Matt Godbolt today at C++ Russia, and that is great. So Matt Godbolt is actually a creator of Compiler Explorer website. So he's passionate about writing efficient code, and he previously worked at trading firm on mobile apps at Google, run his own C++ tools company, and spent more time than a decade making console games. And when I first met Matt, it was at C++ user group in Chicago, a fantastic user group in a fantastic location. And, they introduced just a very funny guy to me, which was fun to chat with. And he was IntelliJ fan. So I decided oh yeah, he's cool. I might maybe want to chat with him more. And he was happy as a kid when I shared some stickers with him. So yeah, later I learned all the thing about the Compiler Explorer and how great Matt is as a speaker. And I'm really happy we have Matt here. So I was waiting that for ages. And so we'll have a great interview today. But to a little bit warm us all up, so with the help of Sergey, our second host, we'll try to run some kind of a blitz interview first. So we'll be asking you, Matt, a few questions, and you have to answer immediately. So please don't think about the answers, just answer whatever you have in your head, and that will run as an introduction. Okay, good?
All right.
Let's start.
Yeah.
So how do you feel about your surname being used as a verb?
Embarrassed. Embarrassed about it, really. It's a bit of a mistake. I'm trying to do quick answers here. I can elaborate later if people are interested in more about that. But should we just crack on, or
no? That will do. That will do for now.
Okay, embarrassed is it?
You've switched. How does it come? You've switched from cool games to boring trading.
They are so similar. It's surprising. It's not as cool to introduce yourself at a party as somebody who works in the trading industry than it is when you make games. But essentially, we're doing the same thing. We're trying to make things happen really quickly, and be it more explosions on the screen or faster reacting to the market. So they're actually surprisingly similar.
Yeah, thanks. And I remember the news on that very cold and really freezing winter in Chicago once. How did you survive there?
By staying indoors, which was good preparation for the last few months, as it turns out.
Oh, so you're not prepared. Okay, cool.
So you should have trained in Russia for a little bit.
Right, yes, I think
Siberia.
you folks are probably right. Yes.
Yeah, you probably know that Sergey Platonov, who is one of the program committee member who initially created C++ Russia, he is also the organizer of C++ Siberia. I'm sure Sergey will be happy to have you as a speaker at C++ Siberia, so you should come. It's
in winter.
Actually winter in Siberia. Yeah, you'll get it. Yeah. Okay.
They measure the temperature in Kelvin rather than centigrade, right? Sorry, please go on.
Yeah.
At least it's positive in Kelvin.
Yeah, hopefully. Okay, let's start with the actual interview, and we'll jump right to the Compiler Explorer topic since, that's what you did, actually. We're not going to blame you on that. That's a great service. And what we want to ask you first, if we treat Compiler Explorer as a tool or a service, how does it help developers in their daily job?
That's a really interesting question. So I created it for myself. And so the primary use case that I use is to put in code and just get an idea about how the assembly code comes out, right? My history was started writing just assembly code, and then very reluctantly I learned C, and then very reluctantly I learned C++, and eventually I come around to the idea that maybe C++ compilers are the thing we should trust to write the assembly, rather than sort of begrudgingly accepting them to do it for us. And then when I was experimenting with how the kind of optimizations that compilers could do, I came up with the idea of a compiler explorer, and since then I've learned more and more and more about how good compilers are, and so I feel a lot better about entrusting the compiler to do the work for me. So that's how I use the site. And then I think probably the most wonderful thing that I've discovered is that other people use the site in very different ways. I know people use it to teach programming. I know people use it to teach compiler classes. I know people use it to sort of use it almost like a sketch pad for like template metaprogramming trickery, or does this compile on all these compilers, or just as a paste bin for code, which is amazing. And I'm so lucky that people have discovered that it's useful for other things. So I don't know if it's I know some amongst us here work for companies who make IDEs, but I sort of find it slightly embarrassing almost that sometimes the best way to sort of sketch out code or discover what's going on is not to use something that's locally on your computer, but is to send it halfway around the world to my server so that I can compile it and send it back to you. So I think it's a tool, it's a service. It's all of the above. I don't think I answered your question, but I'm going to stop now.
Thank you, Matt. Our audience might not be aware of the capability.
Got it.
Well, it was fine for me, actually. So let's continue. Our audience might not be aware of all capabilities provided by the Compiler Explorer. Maybe you can briefly overview the tools available there.
Absolutely. So yes, the site initially was just effectively running the compiler for you and outputting just the text assembly code that the compiler generates with a little bit of cleanup. So in fact, it started out as a very small shell script that was just run the compiler, pipe it through a few greps and things, and then just keep doing that. But since then, it's grown up a lot. We have many compilers to pick from. We have a number of post-processing steps that are available, one of which is the tidying up of the code itself so that you don't get to see all of these, the extraneous detail, like all of the debug symbols and things like that aren't necessarily important. Probably the biggest innovation, and probably the only thing that I thought of was something new that I had done, was coloring the background so that you can see the color of the source code, the lines of the source code that map to the equivalent assembly code. And so if there's a red background in the code on this side and a red background on the other side, then these source cut lines became these assembly lines. And you can see how optimization settings and how different things that a compiler can do cause those things to come out of alignment. But we have many other tools. We have like a control flow graph viewer. We have integrations with some of the analyzers, like, you can run with the undefined behavior sanitizers and things. You can run something called OSACA and the Intel code analyzers, the LLVM analyzers, and they will effectively run a simulation of the CPU and tell you how the instructions that were generated actually decode and how they run and how much time they're likely to take on the output. And that's one of my favorite things to do, is to bring up the time graph view of that. It's a bit basic, but there's that's one thing you can do. We support having multiple pieces of source code, multiple compilers per source code, and a diff view. So you can set up having two alternative versions of the same algorithm, perhaps, and then have two different compilers compiling them. And then you can diff the results and have it update in real time so that you can see, like, hey, if I move this thing, if I move these two lines around, then perhaps the compiler doesn't generate any different code. And that was certainly part of the reason that it was written, was to try and prove to people that we can use higher level concepts in C++, like range-based fors and stood algorithms and things. And ultimately, it's equivalent to writing the code out yourself longhand, except it's just easier for the author. Trying to think what else we've got now. I forget myself. There are so many things. I'm blessed that it's being an open source project and having many people who are contributors means that there are features that I don't really know myself. So, but those are the main ones that I know get used. We can make all of these then can be saved as a short link and shared with people, which is why it became a sort of paste bin of the C++ world. Also worth noting that we also support languages other than C++. So if you want to compare C++ and Rust, you can write equivalent code in two editors, one that's in C++ mode, one that's in Rust mode, and see how the outputs differ, or indeed are very similar in many cases, given that Rust and Clang use the same backends. So there's a lot of things that can be done with the site. And I'm embarrassed. I'm sure there's something really key that I've forgotten that it can do.
Yeah, thank you, Matt. I think like you mentioned Rust, that might drive our interview into a completely different direction, but we'll try to stick to the original plan. So do you know any use cases from real life when Compiler Explorer was like saving someone's day, or maybe yours?
I mean, its original use case was, in fact, for range fours. I was working at a trading company, and we were using a very old version of GCC. And as we were moving forward to a newer version of GCC, we could enable C++ OX as it was back then. And we had been bitten because in other languages, Java, using a range for is very different from iterating over a container itself. So in Java, quite reasonably, when you use like a range for, behind the scenes, an iterator is created, an object that represents the iteration, and that's the thing that is sort of walked over the container. And in a trading system such as we were working on, we were trying not to generate garbage, because we didn't want the garbage collector to kick in, or whatever reasons. Again, I'm not going to derail us into other languages right now, but we had been bitten by someone quite reasonably changing the source code from an int I equals 0, I is less than container.size plus plus I style iteration into a range-based iteration, because it looks better and humans can understand what's going on, but they had inadvertently caused everything to slow down. So when we were looking at the same equivalent transformations in C++, we had to ask ourselves, is this going to slow our code down? Is this going to make everything run slower? And so that's when the idea for Compiler Explorer was born. I wrote the little shell script that I talked about before, and I was able to kind of go back and forth between two implementations and show that the code was identical. And so that was like the beginning of the way that I use it. And then in many cases, and I'm very guilty of this as a games programmer at heart, I want to outsmart the compiler, right? I know things that the compiler doesn't know, because I'm the person, right? I have the intentions of the code. I know what I want to achieve. And very often I have an probably wrong understanding of how the compiler should generate code to achieve my goals in my head. And so I'll write the code as if I'm really treating it like a sort of terrible macro assembler. And sometimes, you remember, you kind of like, you'd put things into you'd put things into variables that otherwise you wouldn't have done, or you put like the register keyword back in the old days, or you kind of manually unwind loops so that you use pointers to walk over things rather than counting indexes, or all these kind of transformations you might do. And some of those things come so naturally, you don't even know that you're doing them. And then, somebody looks at your code and says, I don't really understand this code. What on earth is going on here? And you're like, well, I've done all these things, and you've kidded yourself that they were required. And then you can use something like Compiler Explorer to argue, and as I do now, with sort of those folks who are a little bit set in their ways, to say, well, your code, it's great, it works, it has tests, I love it, but these 12 lines of complicated code can be replaced with, a std transform of something, and the code comes out actually faster, because the compiler knows what you're trying to achieve. You haven't tried to hide it from it by second guessing. So it gets often used in my world for those kinds of things, as well as like taking snippets of code and showing how moving between different versions of GCC might improve things, or in some cases pessimize code, or sometimes filing compiler bugs with the GCC authors or the Clang authors. It's useful to be able to say, this particular version of GCC has the bug, but not this other version, and I can send you a short link that is pretty much guaranteed fingers crossed, to remain permanent, and therefore, it's okay to put in the bug trackers. But that's how I use it on a day-to-day basis. I know other folks use it for other reasons, but I have seen it as touted as like the argument ender. So when people are arguing about whether they should do it one way or another, it's like we paste it into Compiler Explorer, and actually, yes, it's fine. We don't have to do all that complicated stuff. We can just let the compiler do the code for us.
Okay, thank you. Can you point out what was the most surprising thing that you learned yourself with the help of the Compiler Explorer?
Yes, I actually, that's a good question. This one was a real surprise to me. So I've done presentations before on like the kinds of things compilers can do behind the scenes, and most of these have been learned through just experimenting with Compiler Explorer, and I think that's a kind of, just as an aside, that kind of flow is something that us C++ developers are not used to. Now, if you've programmed in scripting languages at all, Python and other, JavaScript, you're used to tinkering in a sort of REPL. I'm just going to, I'm going to print out some things. And Compiler Explorer isn't a REPL by any stretch of the imagination, but it has the same feel. It's got this fast feedback loop. So you can start playing with things and you start to learn interesting things. So in one of my conference talks, I talk about some of the tricks that compilers can do to avoid multiplying operations. Multiplies are fast in processors, but they're not as fast as adds and shifts. And as we all know, and this is exactly the kind of game programmer thing that I have in my head, if you were going to multiply by a power of 2, one would probably use a shift, right? You would replace the multiply by 256 with a shift up by 8, for example. That would be something that I would instinctively do, and because it's faster than a multiply. But of course, the compiler knows this too. It is quite capable of taking the multiply by 256 and turning it into a shift if it's appropriate, which sometimes it actually isn't, signed reasons and such like. Anyway, I'm getting myself out of turn here. I have a skit where I talk about multiplying by different constants, and I show the code that the compiler is generating. So, multiply by 1, obviously it doesn't do anything. 2, it uses, surprisingly, not a shift, it uses an instruction on x86. And all of the various powers of 2 up to like 8, plus or minus 1, it can use this LEA instruction, which is meant for addressing, but you can torture it into doing a multiply by 8 or 7 or 9 and these kinds of things, which is kind of fun. And then a bit more than that, and you can see that it's building out of shifts and adds. And then I picked some random constant and just a big constant, type it in. And finally the compiler goes, no, I'm just going to do a mul with that constant. And you're like, oh, that's a shame. You have generated a multiply instruction. I was trying to avoid it. And so I scratched my head and thought, well, what would game programmer Matt have done? If I know I can't use a multiply here. I know I would work out which shifts and adds correspond to multiplying by that constant. And so I'll do what the job that I think the compiler should do, right? It's I think it's 65599 was the magic number I picked up, and you shift it up by 16 and 13, and you subtract the first one, and that gives you the answer, right? And you type that in, and the compiler runs and instantly replaces it with a multiply by 65599. It actually takes my adds and shifts and says, you're doing something stupid here. Adds and shifts are slower now than multiplies. I will turn it back into the multiply, which is amazing. So the compiler is smart enough to recognize that you are essentially multiplying, even though you didn't write a multiply, and it knows that on the revision of the CPU you're on, it's actually faster to multiply with a constant than it is to do all the shifts and adds. And the cool thing about the compiler is that if you fiddle with the mCPU option and say target a 486 or an original Pentium, then it does indeed use shifts and adds for you. And so the compiler knows, right? You can switch it backwards and forwards between all these different revisions, and you can, as long as you tell it which chip it's targeting, and if it's a chip in the last 15 years, it's going to use a multiply for this. So that was a surprise for me, like how clever the compiler is. Another one that I really like is the fact that all the major compilers now will recognize things like counting the number of set bits. So if you've ever needed to count the number of set bits in an integer, which is used sometimes for like packed matrices, or I think actually the original Quake compressed its bit field of which sectors are visible from which other sectors using this kind of trick. if you ever need to, you need to count the number of set bits that are in a binary number. And you can write a loop to do it. There's all sorts of nice tricks for doing it. But most compilers will recognize those loops now. And, this is like a half dozen lines of code. And they will replace the entire thing with a single instruction that says count the number of set bits, because there is an instruction in most CPUs these days that can do it. And the fact that compilers can look through my terrible code and realize what I'm trying to achieve and then replace my rubbish implementation with, in one case, the right instruction, the multiply, in another case with an instruction which is just tailor-made to do my entire function, is amazing, right? That's just so clever. And there's a number of things like that. So yeah, those are the kinds of things that I'm always amazed by what I've discovered using Compiler Explorer.
Yeah, thank you, Matt. A little bit unserious question, because it seems that people continue thinking about the name for this interview. So, and the question is, people often say, "Oh, you need to Godbolt this," or "Godbolt that." What do you say instead?
Yeah, so I guess we didn't really cover that, but so when Compiler Explorer was first created, in fact, it was called GCC Explorer because it only supported GCC, and I hosted it on my own domain. I have godbolt.org for my email address, and I hosted it at gcc.godbolt.org. And then as time ticked on and I supported more than GCC, I realized that gcc.blah, it wasn't right. So I actually gave up my domain name, as I wasn't using it for anything else, and thought, well, okay, anything.godbolt.org will go to the equivalent compiler or language or whatever. But I'd never really thought twice about it, right? For me, it's Compiler Explorer. After we took out the GCC specifics, it became Compiler Explorer, and that's what I call it, and that's what I remained calling it. I will put code on Compiler Explorer, I'll run it through Compiler Explorer. Those are the kind of things that I will use. But for the vast majority of people, they don't know that that's my name. And it just sounds like a cool name. And people have explained it to me, or I've seen people write stuff on Reddit, sort of saying, but it makes so much sense, right? I've kind of internalized it as being the verb or the noun that makes, bolting something. I don't know. God, is it good? I don't know. There's some kind of feeling that this might actually be a good name for the thing that it does, which is really surprising to me, and not in a small way, embarrassing, like I said earlier. So you won't find me saying Godbolting it other than in that one phrase just then. But I know many people do, and it's an interesting situation. And for the longest, I have compilerexplorer.com and I have some other domains, and they all work as well. But somebody took me to one side and said, you know what? It's short. It's memorable. You've kind of built a brand out of it. I wouldn't recommend that you change it now. And so I've reluctantly accepted that everyone else, or many other people, might use my name as a verb or a noun, but I won't. So that's why. I've been in C++ committee meetings before now, where someone near the front has said, "Can we just put this in Godbolt and see what happens?" And I'm like, "I am right behind you."
Okay, so can you share what is the overall statistics of the Compiler Explorer's daily work? How many users per day, week, or month? How many compilations per second?
Yeah, absolutely. So I do try and make some of these stats public. We're actually experimenting. So there's 3 or 4 of us that are on like a core team who have like the keys to the kingdom in terms of like logging into the servers that and administrating them. And we've been experimenting recently with different statistics platforms so that we can try and publish them. The whole site is open source, both the code for Compiler Explorer, so you can pull down Compiler Explorer and just run it locally, and also the infrastructure, so all the AWS setup and scripts that run and maintain and manage the site, that's also open source. So if someone wanted to make a clone of Compiler Explorer, they could do so relatively easily. Anyway, coming back to your question, the daily statistics are, I think we do, actually I'm going to have to bring them up behind you here, which is rather embarrassing because I have the loudest keyboard in the world. Let's go to stat, and of course I've been logged out. So in terms of compiles per second, I don't think we do compiles per second. I think we probably did 2 or 3 compiles per second maybe. All right, here are the stats. As of today, we are doing 5,000 compiles every 15 minutes. And if I get this up 1 year in 1 week, I'm so sorry, this is the most boring thing for anyone to see. Yeah, we're doing about 2 million compiles a week, which is quite a lot. And the peak bursts come in at like 6 or 7 compiles per second, but most of the time it's 1 or 2 compiles a second. We, in terms of number of active users, we don't really have a good estimate for it. We have Google Analytics, which lets us do some amount of tracking about who's there, but we also have a very upfront cookie policy and a very upfront privacy policy. And when we brought those into so that they popped up immediately and said, hey, do we want to use cookies or not? We noticed that in terms of the numbers of people that we were seeing, about 2/3 of them disappeared overnight when we did that. So we know that like roughly 2/3 of the people who use the site probably opt out of the cookies, probably. But then in terms of active users, we have somewhere in the region of like 500 active users a day, I think. I'd have to log into Google Analytics to have a look, but it's low thousands for a month. But yeah, the only thing we can definitely measure with some certainty is the number of compiles. And as I say, we're doing a couple of million a week. And when conferences, when CPPCon is up and going, we see more like 2.5 million there. Nearly 2.3 million is what we hit a few weeks back.
Continuing about the stats, can you tell us about what are the most popular compilers and programming languages, and what is the distribution?
The distribution of those things is actually a little trickier. We made a change about 2 years ago, which means that the compiler is no longer obviously in the URL that the client uses when it's connecting to the server. It just posts to a compile endpoint, and because we don't keep any information that the users send to us, privacy is very important to us. It means that we unfortunately lost the ability to easily break down who was using what compiler. So again, we've only got the Google Analytics side of things. Now we plan on making a bit of a change with our new tracking on the server side to keep metrics and statistics that are obviously very anonymized, so that no information is being leaked. But the vast majority of compilers are C++. From what we can tell, the vast majority of compilers are either the default GCC, because that's the thing that most people will just go to the site and use the compiler that's there. But in terms of the ones that actually picked on purpose, and again, this is of the subset of people that have enabled Google Analytics, Clang, Trunk, and GCC Trunk are head and shoulders the most go-to compilers. And then there's an incredibly long tail of all of the other compilers. As you might imagine, there's the next one down is the current version of Clang, the release version of Clang, Clang 11 or GCC 10 being specifically picked. And then after that, you get people picking strange MIPS compilers from the mid 90s and other things, because people are just experimenting and trying out stuff. And we have around 600 compilers now. Actually, I say that, I think we have 600 gigabytes of compilers. I don't know if we have 600 compilers, actual compilers, because we double count them sometimes, because we have the C version of the compiler and the C++ version of the compiler, so that adds into it. But managing that has been really the thing that has taken up the majority of my time as a sort of site runner administrator, is just dealing with that number of compiles. I mean, if anyone who's had to install a compiler and then use it and make sure it works and all the library paths are set up and all the include paths are set up, will I'm sure have sympathy with me right now in terms of that. And I have a strange sense of wanting to be able to know the provenance of my compiler, where it came from. So a lot of people will ask us, can we just install this thing? It's just this zip file that you unpack, or it's just this apt thing that you sudo install. I'm like, well, that's not how it works for us. I want to build it from source, so that if there's a bug, if someone from that compiler says, where all did you get this compiler from, I can put my hand on my heart and say, look, it came from this source code, came from over here, so that I can track it back, and it's then useful to the compiler developers. But that's also just because I like doing that kind of thing.
So, talking about compilers, do you collect any statistics on internal compiler errors?
So that's a really interesting one. I do know that when I sort of run the log tailer that tails all of the different logs from all of the compiler explorer instances, I do see a lot of seg faults. So I know that people are causing compilers to crash, which is, of course, fun. A lot of those are in people's own code that they've written. So about 2 years ago, we actually allowed people to start running their own code, which was an interesting security choice to make. And I've learned a lot about all the various types of attacks that one can reasonably expect when you allow anyone to just compile and run their own code on your servers. But that's a separate question, I'm sure. So in terms of the compilers crashing, I don't keep statistics on them, but I am actually talking with some folks at backtrace.io about trying to use their product to aggregate and bring together for compiler vendors the kinds of crashes that we're seeing. Now, obviously, we have to be a bit careful about that because privacy concerns are paramount. I don't want to have core dumps of people's precious code and then just handing them out willy-nilly to people. That's obviously not what we want. So it'd probably be an opt-in choice by users saying, hey, yes, my code is fair game for you to use. And then obviously we don't want to swamp the compiler authors with all of these crash dumps for long fixed bugs. So obviously we have older code, we have older compilers on the site, and some of them have known bugs that will cause crashes, and we don't want to keep pestering the developers with that. But it's definitely on our minds, and it's definitely something I'd like to do. It's a golden opportunity, certainly, to be able to provide the kind of statistics to folks. And in terms of like the whole auditing of our statistics and coming up with this new way of tracking what's going on, we're sort of opening the door to trying to have a way of doing more like aggregated, anonymized analysis, perhaps for academic purposes even. So, for example, a question was asked as, where do the most compiler errors come from, right? Is it when people are using templates? Is it when people are using concepts and misusing concepts? You know, we could start doing these kinds of analyses if we kept some amount of aggregated information on our side. But again, that's a dangerous privacy edge to walk, to be able to get an unbiased sample for our friends who want this kind of information, and B, to obviously protect above all our users' precious code that they're entrusting us with.
Yeah, thank you,
Well,
Matt.
I'd rather opt in.
Right, thank you, sir.
Yeah, me
Yes,
too.
yeah. Obviously, I mean,
Because I have
it's
I've sex-faulted several compilers, and it's fun.
it is a fun thing. I mean, one thing that I do say is obviously we have a very clear and upfront privacy policy, which is I think probably the only privacy policy for me to have ever received fan mail about. I've had 3 or 4 people email me and say, thank you for this. Can we use it as a template for ours? I'm like, yes, that's great. But I back up the idea that, like, you know, we are definitely not going to look at your code. You know, working in the trading industry in particular, you could imagine that a competitor trading company might reasonably want to use the site and then go, wait a second, Matt works for this company. We're sending our code to him. And I'm like, I don't have time to read through 2 million compiles a week. I don't care. Nor can I really. I mean, I probably could if I really put my mind to it. But we go out of our way to make it hard to do that kind of thing. But the way that I square it with myself is I've made it as straightforward as possible to run your own local instance of Compiler Explorer. And I know that many larger corporations have their own instances running. I know Amazon do and Google do, and I'm pretty sure, oh gosh, I heard someone else the other day, but there's at least 2 or 3 big organizations that have like non-trivial sized internal Compiler Explorer sort of clusters to serve their developers' needs. And then, of course, that sidesteps all of the privacy issues. And it also means you can point it at your own build of your own compiler if you have your own funny settings or if you have access to a compiler that we don't.
By the way, let's talk about it a little bit more. So, because some people say that like they use Compiler Explorer as their main IDE, and so they're very interested in a standalone version. So, and as you said, you can run Compiler Explorer locally. So, is it like fully equivalent to the online version?
So if you run it locally, it will use your own compilers that you have on your own account. It's primarily developed on, running on, and all my systems are Linux based. So you'll definitely get the most mileage out of running it on a Linux system. It's known to work on Mac, and it can work on Windows with the WSL, and I think without the WSL. I think somebody's worked on that recently. So it does just work, but with obviously only your own compilers. So if you want to have the full range of compilers that Compiler Explorer has, then you need, first of all, 600 gigabytes of spare disk space, which is not ideal for most. But if you do want that, and especially if you're on a Linux machine, then, as I said, all of the infrastructural tools are available. And I've also made all of the S3 buckets where all of the, at least public open source compiler builds, they're all open. And we have a little tool called ce_install that can let you install those on your machine. And so you can, if you want around about 600 gigabytes of hard disk space taken up, you can just run ce install and then install, and then just go away for a very long time while you pull down all the compilers and unpack them into a directory. And then you can get an almost full Compiler Explorer running locally. There's some configuration is a bit of a pain. It's not a great story for an end user, but it can be done. And certainly that's how I develop. I don't have any special access to the Compiler Explorer when I'm developing. I just have a whole bunch of compilers in a particular place and a configuration file that points to it, and then I just git clone and run. But we have been asked about standalone versions. Yeah. So we've been asked about standalone versions too.
Sorry.
No, not at all. Sorry, it's the delay, isn't it? I'm sorry, I'm so far away from you. I'm what, 6,000 miles away, something like that. So it takes a little while.
Yeah, about that.
Yeah. We've been asked about a standalone version, and we've got some ideas for how we can make like a small, like almost like a Electron app, a bit like, you know, if you have Slack or Discord as a sort of standalone app, an app version that can perhaps even bundle one or two compilers. So we're thinking about these things. All right, I'm done for now. I'll let you go back over to you, Sergey.
Okay. So I can confirm that it does run locally on Mac. I've been using it for a while. It does. So
that's good to know.
You mentioned that the thing that you were amazed with, that the compiler can replace tons of ugly code with instruction just count the bits. So don't you think that this actually shows how limited C++ is, rather than how amazing compilers are? So it means that C++ doesn't have a nice way to express just count the number of set bits.
So that's an interesting one. I think if you use a std, is there a std bit set? Am I remembering? There is something like that. I think if you use one of the STL containers that effectively boils down to the same thing, and then you use the count function on it, it does generate also a pop count instruction, but not, I think, because they've necessarily written it that way. But yeah, I think in general, what C++ is really great at doing is abstracting away from the machine. Like there is all the major compilers have, you know, double underscore built-in underscore pop count or similar intrinsics that map down to the instruction that does the bit counting. But you don't have to know or have an encyclopedic knowledge of your architecture in order to take advantage of the fact that if I write it normally, and I mean, there's not really a normal way to count numbers of set bits, admittedly, right? There's 20 different ways of doing it. But if you write it in the way that's intention revealing, perhaps if you use a std bit set or whatever and use .count, then you know that you are expressing the intention to another reader of the code. Maybe it's yourself tomorrow, and you're like, what the heck is this piece of code doing? Oh, I know, it's counting the number of bits because it's bits.count. I see, right. But you know, if you have to bring out the Intel hardware manuals every time to work out what the hell, like some of these strange parallel double add things with the number you first thought of multiplied by some other thing, you know, carryless multiply. What the heck is all this type of stuff? You know, like it's better to rely on. Most of the time, it's better to rely on the compiler to be smart about applying clever transformations to your code than it is for you to have to memorize them all yourself and understand them all yourself. But of course, C++ does allow for this kind of interaction. If you are working with a custom chip or a custom instruction that you just need to have happen here, you have two options. You can usually use the intrinsic, which is of course not really part of the C++ standard, but pragmatically every compiler will let you do the intrinsics. Or you can just open up an assembly block, and with most compilers, again, there's quite a good low friction interface between just writing the assembly that you absolutely need here and the C++ outside. So I think C++ has done a very good job of allowing the gradation between straight assembly through C-like code, through object-based C-like code, through virtual pointer-based dispatch. Like the Linux kernel is all C, but it effectively uses virtual pointers to dispatch for like file systems and things. But we can make it better in C++ by actually making them virtual. We get some help from the compiler through template metaprogramming, where I can build programs at compile time, through Const Explorer, where I can do the same, through whatever's coming next. Some of the crazy and amazing things that are in the pipeline or have been sketched at, where generative code approaches and real reflection and stuff like that will give us this huge reach between directly typing assembly and specifying programs in very abstract ways and letting the compiler do all of the hard work for us. And we can move up and down that chain as it is required. And very often you don't have to go so close to the assembly, I've found. And that's coming from somebody who worked in trading, and we found that most of the time you can get away with just writing the code the good old-fashioned way and relying on the compiler to do the hard work for you.
Thanks, Matt. As a follow-up to the standalone setups, so the question from our audience is, why not Docker images for standalone instances with different compilers for stable version?
That's not a bad idea, actually. So Compiler Explorer started out being Docker-based itself, and then I spent probably 6 years cursing and swearing at that, because with many hundreds of gigabytes of compilers, building images took too long and all sorts of things. So there's a whole story behind that. And probably rather unfairly now, I have a sort of an allergic reaction to Docker. But in this particular example, I think that's probably the right thing to do, is to have a Docker image that is a way of shipping the compilers, or a small subset of them. Unfortunately, compilers are usually quite big. Clang particularly is huge. But if we were to ship a Docker image with a couple of GCCs, a couple of Clangs, and a web server built into it, or an Electron app, something, I don't know how we would fit those things together, but that would be a good idea. And I think actually, if memory serves me correctly, there are some GitHub projects that do some of that work. So you might be able to already find a Docker image somewhere that is that, like a build of Compiler Explorer, with a couple of compilers. So we could probably look into doing that and supporting it more officially. But that's a great idea. So thank you, whoever suggested that. I'd forgotten about it.
So, Matt, what about the mobile version? Users are complaining it's not that convenient compared to the web one. Do you have any plans to improve it?
Oh, dear. So the story goes with this is that we, about 4 or 5 years ago, switched our editor panel. So there's a little widget that you type your code into, and in fact the thing that displays the disassembly, we switched from one JavaScript widget library to another, and we now use Monaco, which is the Visual Studio Code editor, and it's really full-featured. It's amazing. We get a lot of great syntax highlighting in the old editor. We get the diff view. We get a lot of cool features from it, which is brilliant, and that's why we were happy with it. Unfortunately, what we didn't get is mobile support. They have the Monaco team have said, look, this is not a goal of ours. We are the Visual Studio Code editor team, right? Our main audience are people typing away on their desktop computers. If it works on mobile, great, but there's no way we're going to be bending over to change things. And unfortunately, it doesn't really work on mobile. So that's the biggest thing that we have hampering us right now. So what we currently have is, so that's part of the problem. The other thing is that we use a kind of windowing library within the web page. That's how you can make those extra panes. That's how you can drag and drop things. That's how Yeah, that's how it's sort of so configurable, the view that you get. And also that doesn't work very well on a cell device because the aspect ratio of the screen that the compilers or the link that you were shared on Twitter is probably not going to match the very long, tall display that you have on your cell phone. It's probably going to be, more of a landscape. So we took a decision that, as a sort of stopgap, read-only access for the common case of, you've seen something on Twitter, you see something on Facebook, you click on the link and it brings up Compiler Explorer website on the cell phone, and you just want to be able to read the code and you just want to be able to see the assembly output. So we put Monaco in read-only mode, and instead of showing those tiles in whatever viewport the original author created, we have like a drop down that lets you select between just one tile at a time. And I think that has improved things a little bit. It's not perfect. We don't have many more plans on this front, unfortunately. One thing we might consider doing is a standalone app. We've done some spikes of it before, and actually, given a URL, you can, on most mobile devices, you can say, "Hey, I'm an app, and I handle that URL." And we've designed the URL format to mostly be decodable outside. We even have server endpoints that basically you can post a short link to, and you get back the JSON document that explains this is the code, here are some editors, so that we're trying to make it easier for people to write an equivalent editor. Because I think the only way we're going to get that level of sort of sophisticated interaction that's anyway decent is to have an app. Or something we looked in was to switch out the editor. If we know that we're on a mobile phone, is to go back to the old editor that we had. But there's so much code, as you can imagine, that tied to how the editor works and the interaction between them. We do have a version that works without JavaScript, which is hilarious. So it just uses text boxes and like regular posts, which was done because one of the authors was just thought it would be a fun thing to do. So we can actually run Compiler Explorer using LYNX links, the Unix command line based web browser. So there might be something we can take from that to use on the mobile, but realistically speaking, my thoughts are, like, we're a very small team of 3. We don't have much time as it is. Mobile is not a huge priority for us because my instinct is that it's just hard to type on a mobile anyway, right? It's different if you have a tablet, but on a tablet it mostly works. But if you're actually trying to edit code on one of these, good luck to you in a way. I don't know that we can do much about it. Being able to view them, I think, is important. So if the person who brought up the question is having problems viewing the links, then perhaps they can ping. And obviously, we're an open source project too. If people have ideas, we would love the help. Absolutely love the help. We all have full-time jobs, and this is as much as we can do in our spare time.
Let's talk a little bit about the compilers, and in particular about the Microsoft compilers there. So my first question would be, like, I know that like Microsoft helps you with the Visual C++ compiler for the service. So is it like still true that they provide it for Compiler Explorer, and do you have other stories of such collaboration on the service?
Yes, so we're very lucky. Obviously, we've become quite noteworthy, and as a result, some companies have come to the fore and said, "Hey, we'd like to do some collaborations with you." So the story about the Microsoft compilers were that we run on Linux, and I'm a Linux user and have been for the last 15 years. I don't know which way up is on Windows. So when people started asking quite reasonably to have MSVC compilers, I fired up an Amazon instance that was Windows, and I spent probably 2 weeks trying to get it prepared and running and feeling like I could put it on the internet as a public service before discovering that just there's so much I don't know about Windows security and Windows architecture and all those things. So that was a no-go. But thankfully, Jason Turner was around, and he was able to help me by getting me set up with Wine, which is the Windows emulator on Linux, which is not really an emulator. It's a kind of just a sort of like conversion layer. And with that, we were just about able to get the Microsoft compilers running on Linux. And so all of the original compilers are very hacky, zip files of files that I've got from various places to build out just enough of the compiler infrastructure to get it running under wine. And if anyone's ever tried to use the compilers, the Microsoft compilers that have wine in parentheses behind them, they'll know that they're very flaky and they don't work all that well. And that's because they're a complete hack. So Microsoft approached me and said, look, we can help you. And I was very glad of the help. And so they actually run a completely different site. They have an instance of Compiler Explorer that they host and that they administrate and that they secure and that they install all of the Microsoft compilers on. And you can actually go directly to it if you're ever interested. If you go to www.godbolt.ms, you get just the Microsoft compilers, and it looks like Compiler Explorer. And I don't think things like creating short links work in the same way as they do for us because we're backed in a different way. But effectively, what we do is we shell out the same mechanism that the browser uses to talk to Compiler Explorer to say, hey, what compilers have you got? Can you do this compile for me? Those kinds of commands that go between the client and the server. I designed from the beginning that servers can do between themselves. And so we can essentially proxy transparently requests for compilers that aren't on the main site. So when Compiler Explorer starts up, it connects to Godbolt.ms and says, hey, what compilers have you got? And it just merges them into its list. And then anytime a compile request comes into Compiler Explorer for one of those compilers, it just defers it back on to Microsoft servers. And that's been a great way of me not being put in harm's way or putting myself in harm's way by putting a Windows machine on the internet without somebody like a real professional who knows what they're doing anything. And it also means that we get the latest compilers and we get the latest libraries. The drawback has been over the years that the communication between the team, the Compiler Explorer team, and whoever is administrating it on Microsoft side has been difficult to keep maintained. But very recently, we've gotten into a good dialogue now with a dedicated resource on the Microsoft side, which is very exciting to me. So we now have a point contact, and they're dedicated now to actually taking all of the things that they've done in their version of the Compiler Explorer code and merge it into the main line so that we're on the same code. And then the only thing that will separate our site from their site is the fact that they have a slightly different way of getting the compilers installed that is currently internal just to Microsoft, but they're even considering opening that, in which case we would be able to run the Microsoft compilers ourselves, just like Microsoft do. And that's a great thing, because that means that when people send us a bug saying, hey, this library isn't installed in the right place, or this version of the compiler isn't there, we're able to help them rather than just say, you'll have to speak to Microsoft or I can help them. So that's the story anyway, and it's getting better. I'm very excited about that. That only happened this week, so we should expect the Microsoft story to get better and better.
Okay, thank you. So speaking about different compilers, how do you track and update the list of the compilers and their versions? I guess there's a hell of them. Is it done by other contributors? Our community was a little bit complaining about the lack of Fortran, PGI, IBM Excel, and some other proprietary compilers.
Yeah, so the way that we've as these projects go, obviously it was started out as just GCC and has grown and grown and grown, and each time you get to a certain level, you look at the bash script that installs all the compilers, and it's become 1,200 lines. You're like, I really should do something about this, but I'm only going to add another 20 lines to add another compiler and so on. But we actually have gone through a process now of tidying up how all the compilers are installed and administrated, and it's a lot more straightforward. So most of the compilers that come in now are community contributed. Again, the infrastructure GitHub repository is open source too. So usually we get a PR against that says, hey, this is where my crazy compiler gets installed. And usually it fits into one of the many types of existing installers that, it's curl this URL and untar it in the directory. Okay, cool, we can handle that. Or it's just this GitHub repo. You need to do this and then you need to just run make install. Okay, we can do that too. Those kinds of things. So then that gets it built and put onto the infrastructure and shared amongst all of the Compiler Explorer nodes. And then a second PR then configures the UI to then use it. So that's usually straightforward for open source compilers or ones that don't have funny end user license agreements. For those ones, that's usually the sticking point, is normally where I have to get involved with like the legal teams at the various companies. So Intel's compiler, for example, we had to get special like dispensation from, because quite recently end user license agreements aren't designed for the case where I'm taking a proprietary compiler that normally you would pay for and making it free to everybody, right? That's a bit of a, that's almost exactly why you normally have an end user license agreement, to stop that kind of thing happening. But so we have a little bit of a discussion back and forth, and then that gets us usually the license for the compiler is something that the company will donate, and then we have to obviously secure it. That's the one thing that isn't open source. Of course, everything else is, but license files get hidden away somewhere. So in terms of like the more arcane proprietary compilers, if they can be relatively straightforward and their end user license agreement appears like it should be okay, it's usually pretty straightforward to add. There's sort of, again, there's two components. There's the installing part, which we just spoke about, and then the configuring part. And if running the compiler looks a little bit like running Clang or running GCC or running one of the existing compilers, it's straightforward. We have like drivers that know how to run that particular compiler, and they're usually configurable enough to make it work. But sometimes the compilers are very obscure and need, they have intermediate files or they have demangling that's different, in which case there's usually a bit of code that needs to run to like deal with that particular instance. And again, we've grown and we have most of the components that are around to make that relatively straightforward. So if you can write a bit of JavaScript to shimmy in and pass the right command line arguments to like do the right thing, then it's usually straightforward. One of the things that is coming up more and more requested are support for the compilers that have like heterogeneous, I can't say that word, compilation modules. So like the CUDAs and sickles embedded inside C++ code with like Magic Pragmas to say, hey, this thing needs to run on the GPU. So we're starting to look at how that would work, and some of the compilers that need that support. And then there are some other compilers for the like proprietary NVIDIA compilers, proprietary, I can't think of the other one now, but like certainly we're working with NVIDIA right now to try and get some of their more unusual compilers available on the site. So by and large, we've been very lucky. Companies, we've reached a sort of critical mass now where companies are approaching us and saying, how do we get our compiler onto your site? Whereas it used to be me begging for free licenses off of Intel and so on.
Talking about all these proprietary compilers and licenses, so have you ever considered the monetization of the service?
That's a really tricky one. Yes, I have. I'm very fortunate. People have approached me a few times and said, you realize you could make this your job. And I've considered it. I think like it being a completely free resource for everyone. I just like the idea that there's not any barrier to anybody using the site. Fairly early on, I decided I didn't want to go down even the freemium route where, it's free to use, but you can get extra things if you pay. I didn't want that either. It didn't feel right for me, especially when I can't dedicate the time that I would otherwise like to sort of justify those features. It took a long while, but I eventually, again, dropping a name again, but Jason Turner talked me into turning to having a Patreon page to at least cover the cost, because for the longest time I was covering the cost myself, right? And it was relatively inexpensive back in the day, but as more and more compiles per week happen, and I need to get more and more resources available. So I begrudgingly accepted a Patreon, and I'm delighted to say that I have enough Patreons to easily cover the running costs, so that's good news. And then I had a number of commercial companies saying, look, we would absolutely love to support you more than Patreon. Can we do something to sponsor you in a slightly more amenable to corporate sensibilities way, something I can do a purchase order for so that I can actually get it through my boss, that kind of thing. And so you may have noticed there's a couple of little icons at the top of the page now, which are like our commercial sponsors. And I don't know how I feel about that. I'm very, very lucky to have them, but it does feel like now I'm sort of setting up. But I don't want it to be more than that. But then I also I need to acknowledge the fact that companies are helping us in a big way, both financially and in terms of licenses and in terms of tooling and other things. So it's not likely to happen anytime soon that it becomes, or in fact, I will almost say it will almost certainly never happen that it becomes a commercial property in of itself. But I will probably continue to have as subtle as I can get them, like support, thank you to thing up on the top of the screen, for the foreseeable future. And I mean the reason why I chose not to try and make this my main job is I use the site every day, right? I use it for my day job. I can't help but paste in code from what I'm doing and see how it would work and sketching out ideas, all the things we've been talking about so far. And I think that gives me a good dog fooding instinct about what's working, what isn't working. And so you can probably tell that the things that work the best are regular C++ related features. Anything that's slightly off the beaten track is probably something that I don't use myself. And certainly all the features that we were talking about earlier that I haven't mentioned are ones that I can't remember and therefore probably aren't as well kept. And that's because I don't use them. I won't see the issues coming up. And if I were to work on it full time, I wouldn't use the site at all. Right, I would be writing JavaScript all day, and I would be writing HTML and CSS, and that would mean I would actually stop needing the site. And I don't think it would be good for the site if I wasn't driving it from a need that I have myself.
Great, thank you. So let's jump to trading. Talking about trading, what are the most important tools in trading for a programmer? Well, except the Compiler Explorer.
Well, obviously, Compiler Explorer, yes. That's an interesting. I mean, trading is a very, very wide subject with obviously lots of places where programmers can be involved in the process. And so where I have been typically has been at the more market making, short holding period time. So what people would call what I would call low latency trading, and what everyone else calls high frequency trading. And my answer to the high frequency thing is, like, very often I don't want to trade with high frequency. I just want to trade the right trades at the right time. And so maybe I trade twice a day, and as long as I acted quickly, that's fine. That's not very high frequency anyway. But what my current role is more in the middle now. I'm looking at things that are more big data, and that they are more quantitative analysis of large amounts of data, terabytes and terabytes of numbers to churn through and deal with in a way that means you can maybe train a model and then have the model ready for trading the next morning. And so there's a lot of like really interesting things. And to some extent, this is a dual problem to what I was doing when I was doing real low latency things. There it was all about the latency. Now it's all about the throughput. And so the tools that help with that are usually just a good understanding of your data, a good understanding of the flow of your program, and having the ability to run decent profiling. But I'm trying to think what would be, for me, tracing and being able to like assign timestamps to things and say, where did this go into my system? Where did it come out of my system? How long did it spend in each part of the system? And obviously you can get off-the-shelf tools that do some of this stuff, and perf and other like sample-based profilers are useful. But what I have found is that certainly in the low latency world, all of the traditional profilers fall over because they're sample-based. And what they will tell you is that you spend 99.9999997% of your time in the busy spin waiting for a network packet. And then the one sample that you're fortunate enough that actually lands in when you're processing something doesn't tell you anything interesting or useful. So the profile, the event-based thing doesn't work as well. Now, it's useful to count cache misses. It's useful to count various other stats inside the CPU, but what I found is that like explicitly putting little fence posts in and having a really efficient and quick way of saying, this is what I'm doing right now. This is the current number of cache misses that I've had. Just put that in a circular buffer somewhere, and some low priority thread can slowly pull it out to disk, and then we can analyze it afterwards. Those are the kind of tools, but I don't know of anything that does that out of the gate. Maybe someone can tell me otherwise. But for all types of programming, and this will expose my biases, I think having a deep, not necessarily not very deep necessarily. What am I trying to think here? An understanding that the rabbit hole goes down a long way, and having some idea about what happens down all of the stages. We were talking about C++ itself and saying, okay, well, there is at the far end, you can be building write a couple of lines of STL, and then all these amazing algorithms come into being, and all of the optimizations happen, and eventually assembly is generated, and that's wonderful. But I think but if you're over here, you understand that there is, I could just write regular C++, or I could just write C, or I could in principle write assembly. I don't think many people do or should be able to write assembly, but knowing that it's there and understanding what it's doing, I think is really important, because it can, despite all my protestations to the contrary, despite me saying that like the compiler explorer says most of the time you don't need to worry about this side. If you're up here, you can just let the compiler do it. What's important is to be able to verify that. So you need to understand enough of the assembly side so that you can look at the code and go, oh, I see that the compiler has done the thing that I wanted. It has elided the copy constructor. It has moved things. It has in place generated the code that I expected it to. The things were in line that I wanted to. And then even more so, that the rabbit hole continues from below the assembly. There's hardware, there's RAM, there's caches, there's microcode, there's internals inside the CPU. And I think in order to be good at the kind of trading, the high frequency trading, you need to be really deep in that world. And then when you're in the high throughput area, you still need to have a decent appreciation of that, because now rather than being dominated by the strange latency spike that came in because the operating system decided to process an NMI from the system management mode or whatever, you're now in the world where it's like, if we just reorient our matrices or chunk the matrices up, now it fits in the L2 cache, and suddenly it goes orders of magnitude faster. And you still need to understand that, even if you're writing it in a very high level language, right? If I'm writing that in matrix operations in C++ using all the template tricks in the world, in order to make it performant, I still have to appreciate that there is a point where the rubber of the tire hits the road and something interesting happens there, and I should have an understanding of that. I'm sorry, that's a very rambly answer to your question, and given that we're running out of time, I should hand back to you to have another question. Or
Yeah, that's fine. That was really interesting. So, but I have a very important question on trading to you, Matt. So, how much money did you earn or lose on trading?
Oh, so I am the world's worst person to ask any of these things. I have worked in trading now for 10 years, and I wouldn't take any advice of me about how to trade. I am I am so bad. I don't really dabble in it personally at all. It is just something I do for much cleverer people who have a much better understanding about what it means in the market. I mean, I picked a little bit up by attrition, but not enough for me to be able to work on.
So, a question from our audience. Is that the original Xbox on the floor near the TV set?
That absolutely is
Yeah.
an original Xbox, yes. I got it because I wanted to show my children one of the games that I worked on. It's very sad. I don't consider myself to be that old, and yet now if I go into a store and I see the retro computing area, some of the games that I worked on are now considered retro, and that's very, very sad. But yeah.
So can you name
Xbox.
some titles?
So the games that I've worked on. So the Xbox game was one of the SWAT franchise, if you know the SWAT, Special Weapons and Tactics, first-person shooter. So it was SWAT Global Strike Team, which no one will have ever heard of. I worked on a Dreamcast game called Red Dog, and so there's a Dreamcast out of shot. This is a break everything. So I've got my Dreamcast at the top of there, and that's actually my favorite console to work on. out of all of the consoles that I worked on. It's so different in terms of the way the 3D rendering was done. It's a really interesting it was a dead end in terms of the technology that they were using, but it was really, really interesting and made for some very high fidelity alpha blending, if you care about such things. So I worked on Red Dog for that. I worked on a PlayStation game, several PlayStation games, PS2 titles. The company I worked for was, for those who are old enough to remember the Super Nintendo era, the company I worked for was a company that designed and built the Super FX chip and programmed Star Fox for the Super Nintendo. So it was a very, very, very early 3D accelerator chip. So I was very lucky to be working with the people that had considered that that's something that you could even do. And I mean, that to me is the most interesting and exciting thing about all of programming.
Sorry, Matt.
It's problem solving. Yes.
I'm sorry, Matt, we're totally running out of time. And I think we can continue in the discussion zone in Zoom. Very nice having you with us tonight or today.
Thank you very much for having me. It's been so much fun.
Yeah, thank you a great
thanks,
deal.
Matt.
It's been amazing. This was by far the most engaging talk of the entire conference. The activity in the chat is, I think, much, much greater than anything I've seen in all the other talks so far, perhaps even combined. So thanks a great deal, Matt. Thanks, Serежа. Thanks, Nastya. You've been great hosts. Great interview. I absolutely loved it. And I definitely invite everyone to the discussion zone where you can ask the rest of the amazing questions that I'm sure everyone has. So please go ahead.